Morning student. In this video we are going to understand motion of the charged particle in a magnetic field. So here we have the different cases when the charged particle enter at different angles, its motion will be different, right? For example, when the charged particle enter, case number 1, here we discuss case 1, when particle enter at theta is equal to 0 degree. So this is the magnetic field, this is the magnetic field, this is positive charge or this is negative charge. Suppose they are moving along the magnetic field. So here theta is 0, F is equal to QVV sine theta. Theta is 0, so force will be 0. So charge will not experience the force, or it will keep on moving. It keeps on moving along the direction of field. So its path will be straight. Its path will be straight, and the motion will be uniform. Means its velocity, this will be the uniform motion. Its velocity will be constant, because it is, although it is moving, but force is 0. So if the force is 0, so velocity will remain constant, we know. So its motion will be uniform, path will be straight. Second case second. Now what is the case second? When particle enter at theta is equal to 180 degree. So what happened at 180 degree? This is the uniform magnetic field, equidistances. It is represented by the equidistances line. Uniform magnetic field means at each and every point magnetic field will be same magnitude wise and direction wise. If it is 2 Tesla east at one point, it will be remain same in every point. So here, suppose this is positive charge, it is moving in this direction, or this is the negative charge, again it is moving in the same direction. So theta is equal to 180. Why it is 180? These are the magnetic field lines, they represent the magnetic field. So magnetic field is in this direction, or charge is moving in the opposite direction. So theta is 180 degree. So force will be QVV sine 180 sine 180 0. So again the path will be straight. Here path will be straight, and because force is 0, motion will be uniform motion in these two cases. So when the charged particle enter in a magnetic field at 0 degree or 180 degree, its path will be straight and it will be its motion will be uniform. Now third case, this is the case third case, when charged particle enter, when the particle enter at an angle, when the particle enter at an angle 90 degree. So what happened? Particle enters at theta is equal to 90 degree, means it implies perpendicular to magnetic field. So here I am taking the magnetic field another equidistances. These are the equidistances point represented by, and this magnetic field is a uniform magnetic field perpendicularly inward. If the magnetic field is represented by equidistances cross points, this is the perpendicularly inward. If the magnetic field is 20 Tesla here, it will be 20, it will be 20 everywhere. Magnetic field assigned to the magnetic field is Tesla, TESLA, Tesla. Okay, and the magnetic field equidistances point, it is perpendicularly outward, and the magnetic field which is like this, it is perpendicularly inward. Now suppose this is the charged particle, and this charged particle enter magnetic field. Now look at this one at an angle. This is the velocity, and magnetic field is inward. So magnetic field is inward, this is the velocity. So the angle is look at this one. This is the magnetic field, this is the velocity. So this angle is 90 degree. Okay. So now what happened at 90 degree? F is equal to QVV sine 90, and this will be QVV sine theta. This F acts perpendicular to velocity always. ये जो फोर्स है जब भी काम करेगा ये वेलोसिटी के परपेंडिकुलर एक्ट करेगा, because of which we represent this force F is equal to Q V cross V. This force is represented by V cross V. So it is the cross product of these two. बट लॉजिक इज नॉट दैट कि इट इज रिप्रेजेंटेड बाय द क्रॉस प्रोडक्ट. लॉजिक ये नहीं है, ये एक्सपेरिमेंटली प्रूव्ड है, नेचुरली ये फोर्स, इसके पीछे कोई लॉजिक नहीं है. जब भी ये फोर्स लगता है तो इट ऑलवेज परपेंडिकुलर टू द वेलोसिटी. सो लुक एट दिस वन, राइट हैंड पाम रूल. हमारा राइट हैंड पाम रूल, ये मैंने जो आपको राइट हैंड पाम रूल बताया है, लेट अस सी द राइट हैंड पाम रूल. दिस इज अवर राइट हैंड this part is wet, so it is difficult to write over here. So suppose this is the right hand, sorry, this is the left hand, not right hand. Suppose this is my right hand. As I told you, cross product जो चीज निकालनी है, that is perpendicular to the palm. This is the direction of the force, and this is the velocity, and this is the magnetic field. B is the magnetic field. So magnetic field finger की तरफ है, ये velocity है, ये right hand palm rule. So I am applying the right hand palm rule. Magnetic field is perpendicular inward. This is the velocity. So this will be the force. This is the magnetic Lorentz force. Now this force is perpendicular velocity. It will change the direction of velocity. Suppose it's change the direction this way. So now suppose the particle is right over here. So this is the velocity, and magnetic field is inward. Magnetic field अंदर की तरफ है. Magnetic field is perpendicular inward. This is the magnetic field is perpendicularly inward. Okay, magnetic field is perpendicular inward. So this is the velocity. This is the magnetic field. This is the velocity along the thumb. So force will be act perpendicular to the palm के perpendicular. So this is the magnetic force. Again, it will take the charged particle right over here. Here you also take the magnetic field. Charged particle must be inside the magnetic field. Suppose this is positive charge V. This is the velocity, and magnetic field is inward. So force will be in. So similarly, if you take everywhere, you take at this point. This is the velocity. Magnetic field is inward. So force will be in this direction. So this force will act always perpendicular velocity. So it will act as a centripetal force. A force which only changes the direction, not the magnitude, and always perpendicular to the velocity. So that force act as a centripetal force. So this force act as a centripetal force, right? So now this force act as a centripetal force, because of which we write F is equal to Q V cross V, right? So now what happened? Every force which acts toward the center, it changes the direction, not the magnitude. It acts as a centripetal force. So if it acts as a centripetal force, so this force will be now this force will be given by if F always perpendicular velocity, and it changes only direction. It changes only direction. It changes only direction of velocity, right? So ये सिर्फ velocity की direction change करता है. So it what happened? It act as centripetal force. So therefore F is equal to mv square by r, because suppose this particle of mass है, ये particle m mass का है और इसकी velocity भी है, तो इसको घूमने के लिए the centripetal force required is mv square by. This is the centripetal force required. Centripetal force एक ऐसा force है, ये इसका formula है, but this force is not itself a force. Then those force which are it is a force, formula of the force. This is the force required by the particle whose mass is m, velocity is v, and moving in the radius r. So if this particle is moving in a radius r in a circular path with velocity v, so this much of force it is required. But who will provide this centripetal force? Which force act as a centripetal force? So in case the charged particle moving in the magnetic field, this magnetic Lorentz force act as a centripetal force. This qvb sin theta provide mv square by r. So because of these two, this now we can write mv square by r is equal to qvv. Vv cancel out, so mv so we can write mv upon r is equal to vv cancel qv, or this r is equal to mv over qv. So this is the radius of circular path, mv over qv. This is the radius. This radius circular path में m mass of the charged particle, v is its velocity, q is its charge, b is the magnetic field. This is the first thing which we get. Second thing is the v time period. Time period 2 pi r over v. What is radius? 2 pi radius is mv over qv upon v. V cancel. This v cancel. So time period is equal to 2 pi m upon qv. This is the time period of the charged particle in circular path. Time period means एक पूरा चक्कर जितने time में लगाएगा. In one complete circle, it will complete in this much of time. Third thing is frequency. Frequency is 1 upon time period. Number of turns, number of circle it will complete in 1 second. That is called frequency. 1 upon time period. So it will be qv over 2 pi m. So this is the frequency. Okay, so this is the radius of the particle in the magnetic field, where, sorry, this is the radius of circular path of a charged particle which is moving in the magnetic field. So this is the motion of the charged particle. So here, when the charged particle enter at an angle 90 degree, what happen? Its path will be circular. It moved in the circular path. So we have discussed theta is equal to 0, theta is equal to 180, theta is equal to 90. Now we have other than these angles, means acute angle, theta is equal to 10 degree, 20 degree, 30 degree, that I will discuss in the separate video. And that in that case, if the theta is not here, we have discussed one case 90 degree, one case 180, one case 0 degree. So one case is other than these three angles, that in that case the path of the circular path of the charged particle will be helical. Helical means the charged particle will not only move in the circular path but also move along the magnetic field. Magnetic field के along भी जाएगा, तो because of combined motion of these two motion, it moves in the helical path. So when the charged particle moves at an angle greater than 0 and less than 90, so its path will be helical, right? So we will discuss it in the separate video. Thank you.